This is 7.4 basic trig equations. So finally, we're going to get to some equation parts using trig. So notice this first thing, we're all familiar with sine squared plus cosine equals 1. That's an identity. That's true for all theta. But now notice if I give some other equation like this, it's true for certain theta. And certain angles it would be true for, but it's not true for all of them. So let's look at some examples and how to find it. So here I give sine of theta equals 1/2. Well, again, we're trying to find what theta is, okay? We're trying to find out what that is. And just like if I said sine of x, okay? So I'm trying to find out what that is. Well, look at the unit circle. So if I look at the unit circle, I'm trying to find out where the sine of what angle gives me 1/2. That's what I'm looking for. Well, I know just on the unit circle, 1/2 sine is right here and right here. So if you look at what angles those are, that's pi over 6 or 30 degrees if you want to look into degree mode. And this is 5 pi over 6 or 150 degrees. Okay, so notice what I found was I literally found the theta is pi over 6. So in other words, sine of pi over 6 is 1/2. See, I solved for it. I found out what theta was. And also sine of 5 pi over 6 is 1/2. So I found theta is pi over 6, but also theta is 5 pi over 6. So there's two possible answers. Now notice what you should always do. This right here is extremely important. So I found theta, what works on the unit circle, and this is for one period, because I could actually go around the circle twice, 3 times, 4 times. So I want to find out all theta that will work. So basically, if I circled again and circled again and circled again, so I want to find all theta. So theta would be pi over 6 plus 2 pi if I went 1 time around the circle. Or if I went 2 times around the circle, then it would be 2 pi times 2, or 3 times, or 4 times. So I don't know how many times we're going to go around. I want to find every possible theta. And so I'm just going to put a variable called k, and k is the number of times that, number of times I'm going around that circle, or the number of periods that's going to take place. So pi over 6 plus 2 pi k, and typically we write pi last, just so it's easier to read. So we would write 2k pi, okay? And then the same thing here. So remember, theta could be possibly there or there at 5 pi over 6. So 5 pi over 6 plus 2k pi. So this is all the possible solutions for theta, depending on how many times I went around the circle. And again, look at it, think of the sine. So I'm going to erase some of this up. So think of it another way, not just the unit circle, but think of the sine graph. So if you thought of the sine graph, remember the sine graph starts here, it goes up to 1, it goes back down, and it keeps repeating itself. So I want to know, when is sine 1/2? Well, it's 1/2 here, it's 1/2 here, it's 1/2 here, it's 1/2 here, it's 1/2 here. So all of and it keeps going on forever. So all of those theta, so that, this is pi over 6 right here, pi over 6. This is 5 pi over 6. And so it keeps repeating itself, plus 2 pi plus, this plus 2 pi is there. This plus 2 pi is there. And so it just keeps repeating itself over and over and over. So first find the solution for one period, and then just continue on 2 pi k after that. All right, so let's look at another solution, another equation. All right, on this one, note it's the exact same thing. I'm trying to find cosine of a x, or theta, that is going to give us negative square root of 2 over 2. Well, we recognize the square root of 2 over 2 is a 45-degree angle, but notice its cosine is negative square root of 2 over 2. So look at all students take calculus. So where is it negative at? It's negative here, and it's negative here. So this right here, the theta, the degree measurement from here to here, that's 3/4 pi, and I know it's 5/4 pi. So this is 3/4 pi, and this is 5/4 pi. So I know the two thetas that fast, okay? Now, how do I want to find 8 specific ones? So normally what we would do is, 3/4 pi plus 2 pi k is, or 2k pi. I'm so used to writing 2 pi, So 2k pi, and again, it does not make a difference. If you wrote 2 pi k, that's fine. It's not a big deal, but typically we want to write pi last, but it doesn't really make a difference. And the same thing here is 5/4 pi plus 2k pi. Now, that's for all k. I don't want all thetas. I want 8 specific ones. So I'm going to literally find 8 specific ones. So 3, 6, 7, 8. Well, I automatically know 2 of them. So I know 3/4 pi and I know 5/4 pi. That's 2 of them. Well, and that's if, k equals at 0. If k equals 0, that's what I get, okay? That's what I did here. So what if I plug k equals 1 in? And what if I added k equals 2? So in other words, 1 time around the circle, 2 times around the circle, and then I would easily get, what I wanted. You could do k equals 3, or you could even do k equals -1. So going the opposite direction. So it doesn't really make a difference, but I want specific numbers in here. So I'm going to stay with this right here. I'm going to do -1, 0, 1, and 2. And again, I went and did this. I basically added, if k is 0, if k is 1 or 2 or -1, I just basically plugged it in here, add 2 pi or 4 pi to it, and then or subtracted 2 pi. And I got all of the 8 specific thetas solving for that would actually equal negative square root of 202, because that's what I'm trying to find. All right, so let's look at this one right here. So cosine of theta equals 0.65. Well, again, this one's not necessarily a triangle that we do know, but we do know how to find theta. So we're literally going to take the inverse cosine of both sides. And so since this is in radians, we're going to do it in radian mode. So we're going to take the inverse cosine of both sides, and you're going to get 0.86. Again, approximately 0.86. And again, keep in mind, we're always trying to find solutions for one period, and it's 0.65. That's a positive number. So all students take calculus. So we're talking about the first and the fourth quadrants. So we're to find, the other theta, that would give me positive 0.65. It would just be 5.42. So I basically took, because I know it's in here, so I basically just took 2 pi, that's all the way around the circle, would actually equal 2 pi minus 0.86. Okay, so because I went from 2 pi and I went backwards or clockwise to get to my answer. So these are my 2 theta. Again, just to double check, cosine of theta, just make sure you understand what I'm doing. Cosine of, we found theta. So cosine of 0.86 equals 0.65 in radian mode. Cosine of 5.42 equals 0.65. That's what we're trying to find, again, in radian mode. All right, and then, again, I want to find all theta, so we're basically just going to add 2k pi. And these would be my solutions for solving that equation. So let's look at 2 more examples here, solving equations. All right, so notice this is actually, just solve it like a normal equation. So you're going to add 1 to both sides, divide by 2, And again, we've already done this. So, where is theta 1/2? So we already know this is pi over 6. And we know it's 5 pi over 6. And I just want to keep reminding you, all students take calculus, so we know it's in the first and the second quadrant. And then plus, we want to know all theta, so 2k pi. So these would be my answers for all theta. And the same thing here, we're going to solve it like a normal equation. So we're going to take tan squared equals 3, take the square root of both sides. So tan theta is plus or minus the square root of 3. So where is tangent of theta the square root of 3? So think of right triangle. So here, where is this? Well, this is a 60 degree or pi over 3. So a 60 degree, this would give us square root of 3, and this would give us 1. So this is literally pi over 3. And then plus 2k or plus k pi. So the reason why this is important is because you have to. This is not 2k pi specifically because if you look where it's positive at, so it's literally adding pi from first and fourth quadrant. So this is k pi, and then again, go back to this? Where is the inverse tangent? Like on this step, where is the inverse tangent? Positive -3. So this is literally at negative pi over 3. Remember, the inverse tangent is defined in these two quadrants. So negative pi over 3, and then plus k pi. And again, check it. Where is tangent of theta? Like literally, you could plug this in. Pi over 3. You could literally check it. Take pi over 3, tangent squared, pi over 3 minus 3, and it should give you 0. And the same thing with negative pi over 3. You could literally check your answers by plugging them in. Just like if I gave you a simple equation, x plus 4 equals 5, and you got x equals 1, you can check it by plugging it in to see if it's true. So you can always check these answers by plugging them back in to see if they actually work. All right, last example. So if I had something like this, 5 sine cosine times cosine plus 4 cosine equals theta, how do I solve that? Well, notice that there's something in common, a GCF in common. So I'm going to factor out cosine of theta. I'm going to have 5 sine of theta plus 4. And just like in algebra, if I had something like this equals 0, then I set this equals 0, and I set that equals 0. So I'm going to do the same thing. So cosine of theta equals 0. And 5 sine of theta plus 4 equals 0. And then you're going to solve those. All right, so notice again, step by step, where is cosine theta equal to 0? Well, think of the unit circle. Right here is 0, 1, and this is 0, -1. So I know at pi over 2 and 3 pi over 2, that's when cosine will equal 0. Over here, solving for theta, sine of theta, I'm going to get -0.8. So you have to think about where is theta going to be -0.8. So again, think of all students taking calculus. So we're talking about in the third and the fourth quadrants. Okay, that's when sine will be -0.8. So again, I just basically took the inverse sine of both sides, and I got -0.93. And then I added pi to it because again, I know it has to be negative in the third and fourth quadrants. So I added pi to it. And then after that, since now I know my theta, I'm just going to add 2k pi. I'm going to add 2k pi. And those are all my possible answers solving for that blue equation up at the top.